Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 14C Part 2 assignment. First one we're going to take a look at here is number 2. A man rolls a regular six-sided die. He wins the number of dollars shown on the uppermost face. Find the expected return from one roll of the die. So what we want to do here is we want to figure out, okay, if he will win, if he rolls a 1, he will win $1. And that is 1/6 of what's 1/6 probability, right? And if he wins, in fact, maybe we can even write it like this: 1 times 1/6 plus, if he rolls a 2, which is 1/6 of the time, he'll get $2 back, plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6, right? So we can put that all in our calculator and see what we get. I guess we really, since all these numerators are just 1, this is going to be 1/6 plus 2, 6 plus 3, 6, 4, 6, 5, 6, and 6, 6. Sorry, that's going a little bit downhill there. That's a 5, by the way. So let's see. These two make 1. These two make 1. That makes 1. So that's 3. That's 3 totals plus another half. So that's 3.5. So the expected return from one roll of the dice is $3.50. Okay. So for B, find the expected gain if it costs $4 to play the game. So you are expected to add $3.50, but you have to pay out $4, so that your expected gain is to lose 50 cents every time you play. Okay, and then would you advise the man to play many games? Nope, because on average you're going to lose 50 cents every time you play. So if you played 10 times, you'd lose $5 over time. Okay. 4, a person pays $5 to play a game with a pair of coins. If 2 heads appear, then $10 is won. If a head and a tail appear, then $3 is won. If 2 tails appear, then $1 is won. Let X be the gain of the person from each game. Find the expected value of X. Maybe we can, this is a pretty simple one. You're only flipping 2 coins, so let's do this. So say first coin, we can either get heads or tails, right? And then on the second coin, we can either get heads or tails. Heads or tails if you got tails on the first coin, right? So if 2 heads appear, $10 is won. So this is 1/4 of the time. So, but this one you win $10, right? And then it says if a head and a tail appear, then $3 is won. That's these two right here. So this is 1/4 and 1/4. These will both earn $3. And then if 2 tails occurs, that's 1/4 of the time. That's $3. And then if 2 tails occurs, $1 is won, right? Okay, so let X be the gain of the person from each game. Find the expected value of X, and you pay $5 per game. So let's find expected return. Okay, so really we can do these all together. We could actually just combine these 2 quarters together to get 1/2 times 3. So it's really 1/4 times 10 plus 1/2 times 3 plus 1/4 times 1. So 1/4 of 10, that's $2.50. Half of 3 is $1.50. And then 1/4 of 1 is 25 cents. So we add those together, 2, 3, $4.25, right? So 4.25 our expected gain, but it costs $5 to play the game, so it's going to, the expected value of X is going to be, you gain 425, but you have to pay $5, so that's going to be an expected gain of 75-cent loss on average every time that you play. Okay? All right, one more to take a look at here. Number 6, a person selects a disc from a bag containing 10 black discs, 4 blue discs, and 1 gold disc. They win $1 for a black disc, $5 for a blue disc, and $20 for the gold disc. Game costs $4 to play. Calculate the expected gain for this game and hence show that the game is not fair. They're not fair. Okay, so there is, to get the black disc, you get $1 for getting a black disc, and that is 10 out of the 15 total, right? Because 10 plus 4 plus 1 is 15. And then you get $5 for the blue disc, and that is 4 out of the 15. And then you get $20 for the 1/15th chance that you get a gold disc. And it costs $4 to play. So let's figure out what all these are going to be. So that's 10/15ths. 5 times 4 is 20 over 15. 20 times 1 is also 20 over 15. So we add those all up, and that's 50 over 15. So 50 divided by 15 gives us $3.33. Our expected return, but again, it costs $4 to play, so you'd have to do $3.33 minus $4 for an expected gain of negative 67 cents. So since if it's a completely fair game, this would have to be 0. So that shows that it is not fair. That's part A. And then part B, to make the game fair, prize money for selecting the gold disc is increased. Find the new prize money for selecting the gold disc. Okay, so we know that these two are going to be the same. And then we have to add we have to add something in here so that we end up equaling, costs $4 to play, so it's got to equal 4, right? So let's do this. 10/15ths plus 20/15ths is 30/15ths plus x over 15 equals 4. This is simply 2, right? So we subtract 2 from both sides, and we get x over 15 has to equal 4 minus 2 is 2. We can just do cross products here. 2 times 15 is 30. 1 times x is x. So we have to increase that thing up to $30 so that it makes it a fair game. Okay. Okay. That's all we have for the 14C Part 2 problems. If you have any further questions on any of these, please feel free to ask. Thanks.